C#. So C# was Microsoft's answer to their loss of the lawsuit. And C# took a slightly different approach than Java. So here I'm going to steal this middle column here from Java, bring it over to this slide. So as a reminder, this is Java's approach. Okay, so we have our Java source code. We compile it down to Java bytecode. It runs in a virtual machine, which interprets it for the platform it's running on for that CPU. So we're going to take our C# source code. We're going to compile that. It compiles down to Missile code, Microsoft Intermediate language, which is also a low-level language. Remember earlier I referred to Java bytecode as an intermediate language? So Missile code is Microsoft's version of Java bytecode. All right. Then actually, let me do this. Well, let's do it this way. Then it runs on the .NET component architecture. Which runs through some just-in-time compilers, JITs. Ultimately running on Windows for the Intel CPU. Now, at a glance, these two things look pretty much identical. They both start with high-level source code. They both are compiled. They both go down to an intermediate language. They both run on something, this layer here. This one's a virtual machine. This one's called the .NET component architecture. The virtual machine interprets for the CPU. This other thing uses this new invention called the just-in-time compilers. Okay? So at first glance, these don't look that dissimilar. Right? The big thing is right here. The just-in-time compilers, and it uses the word compiler instead of interpreter, what they do is they only run once. So they actually turn the Missile code into native code, which runs natively on Windows and the Intel CPU. So the very first time you run a C# program, it's going to run a little slower. It's going to take a little longer to start up because it's having to run things through the just-in-time compiler. But once it's compiled at once, now it's native code for that platform. Make sense? So that's cool. Now, Java, we've already seen, is platform independent. C# is also platform independent. That is, it's platform independent on any platform that supports the .NET component architecture, which means that it's platform independent as long as you're running Windows. You can run on any platform. as long as it's Windows. Okay, so C#, Java, both these guys live in a very similar world. Microsoft did take the opportunity when they created their new language to make some improvements on Java's model, and since this time, Java has actually incorporated some just-in-time compilers into their system as well to try to speed things up a little bit. They don't have the luxury, though, of needing things to only work on one platform. They still have to deal with their portable virtual machines. The fact that they've written this Java virtual machine for Windows, for Mac, for Linux, they've written it for multiple platforms. You know, Microsoft has written their .NET component architecture for every single platform they intend their C# programs to run on. That is Windows. Now, having said that, there is kind of an interesting factoid with the .NET languages. So C# is considered one of the .NET languages. So .NET languages would be C++, C#, VB. They actually have a new one. Let's just leave it at that. It's not important. So let's say you have these three languages. The cool thing with the .NET languages is they all compile to Missile code. That's Microsoft Intermediate Language. So they all compile down to that, which ultimately means that if it made sense for you, you can write part of a project in C++, another part of your project in C#, and another part of your project in VB, and have them all run together on .NET. Because they ultimately are all compiling down to the same intermediate language. Now, that might not seem entirely helpful. I think most people who write software pick a language and stick with it, but given that you'd be using the same tool, the Visual Studio tool, to write any of these languages, for instance, maybe doing front-end development for your graphic user interface might make more sense in VB for certain things. C# is going to have probably the easiest to use network libraries out of all three of these. So maybe if you're doing a lot of internet stuff, maybe you do the networking stuff using C#. You know, at the end of the day, this is probably more of a circus trick than something that's really beneficial, but it is of interest to throw out there. All right, questions about any of that stuff? All right, so let's revisit a slide from up here. Back to this, how do human beings solve problems? So I've already told you that the language we're going to use in here is Java. We've now sort of seen where Java fits in the world. Okay. We've talked somewhat about the big three languages. That's Java, C#, and Objective-C. If we were talking about those in terms of industry, if you're a Windows programmer, you're using C# today. VB is the dying breed. Visual Basic stayed alive for a long time because it was what was called a rapid application development tool, RAD tool, where you can create graphical user interfaces very, very quickly with Visual Basic. Well, now you can do the exact same thing with C# with their interface builder, but you have the luxury of, I think it's fair to say, the superior language that is C# over Visual Basic. Visual Basic was really a language that was developed during a transitional period where the idea was there was people who weren't programmers were doing programming. So Visual Basic was created as a tool to allow non-programmers to hunt and peck their way towards programming solutions. And I think more times than not, it caused problems. C# is a much more complex language than Visual Basic. How many of you have ever written anything in Visual Basic? Okay, so Visual Basic would actually become kind of this hybrid-y language compared to some of these other things we've talked about. It's only sort of object-oriented. It's definitely compiled. It's loosely typed if you want. It's very much a hodgepodge language, which actually makes it difficult to be consistent in. So you can find Visual Basic examples online where everybody has defined what kind of variables they're using, which would be a strongly typed language. The keyword in Visual Basic is something called dim, for dimension a variable. In fact, you can say either dim or you can say dimension. Or you can choose not to say anything. You could say, this is just a variable. I'm going to use this guy. And I'm not even going to tell you what he holds. So it's like Visual Basic tried to be everything in one language to the point where there's like no rules. It's done well for itself. It probably allowed a lot of kind of simple utilities to get into the business world that wouldn't have existed otherwise. But in terms of a true development tool today, I don't think Visual Basic is heavily used, except for maintaining older software. I think most of the business, computer programming has become an industry in and of itself now, where Visual Basic lived at a time where we're really transitioning in the earlier days of the internet and things like that. So I think most of the time today, if a company needs some custom software, they're going to hire programmers to write the custom software. They'll either bring 2 or 3 programmers in-house to do it, or they'll outsource to a software company to do it. And those companies would probably not be using Visual Basic. They would be using more modern tool like C# or Java or Objective-C if it was on the Mac. Okay, so anyways, back to this idea of how do human beings solve problems, and remembering that programming languages attempt to simulate the way human beings solve problems, we need to talk about each of these things in passing as our introduction into Java. So first thing we're going to look at is this idea of variables, which is our way of simulating memory. Okay, so a variable is a named placeholder in memory which is capable of holding a value. Okay. There are 2 types of variables. I promise this is actually the only slide like this one. We have primitive type variables, and we have object type variables. We are not going to get into object type variables yet, but we will in this course. But I'll give you the overview definition of both of these. A primitive type variable is a variable type built into the language which is only capable of holding a single value. Notice the emphasis on only. I capitalized it. So primitive types are variable types that are built into the language and they can only hold a single value. That's the extent of their talents. Object type variables is a variable type that is either built into the language or user defined that can hold 0 or more values and potentially do more through methods. We don't know what those are yet, but objects are like super variables. They can do more than just hold a value. That's how we should think of them in our heads for right now. We're going to be looking at primitive types for a little bit. All right. So, let's talk about the primitive types in Java. In Java, we have byte, short, int, long, char, float, double, Boolean. Those are all of the primitive types in Java. We're going to talk about each of these. All right, bytes. Now remember, primitive types can only hold a value. Now remember, Java is a strongly typed language. So when we define a variable in Java, we must define the type, one of these guys, that variable was built to hold. Okay? So bytes hold whole numbers. Shorts hold whole numbers. In fact, here I'm gonna whole numbers is fine for right now. Ints hold whole numbers. Longs hold whole numbers. Okay, now wait a minute. Why do we need 4 different types for holding the same crap? What do you think? Whole numbers being integers, like the number 7, or the number -4, the number 237, not like the number 3.14. So these are whole integer values. Why do I need 4 different kinds of primitive types that all hold the same kind of crap? Remember, go back here. Java, its parent was C++, whose parent was C. Back in the C days, see, this list of primitive types here, same list for C++, same list for C. These were passed down through the generations of languages. Okay, this isn't something Java invented. This is, hey, you were a C++ programmer, you can be a Java programmer now because you already know most of the syntax. Same thing with, hey, you're a C programmer, you can be a C++ programmer. You can also be a Java programmer. Back in the days of C, C was a language designed for writing operating systems. How many of you have heard of the Y2k bug? What was that?
The date.
Okay, what about it?
Earlier, the date was the year was considered just 2 digits, like 99, 97, 98, and when it came to 2000, then there's going to be a null value because there's no date field there.
Why were the dates in some of the software stored as 2 digits instead of 4? So the Y2k bug, the problem is we had all this software that when the year rolled from 1999 to 2000, the software would be confused. Is it the year 2000 or is it the year 1900? 00 looks the same to me, right? So the question is why was so many of those software packages written to keep track of 2-digit years instead of 4-digit years? Why didn't they keep track of 1999, then 2000? So they would have a distinction between 1900 and 2000. Why were they written with 2-digit years instead of 4-digit years? A lot of that software was written in the 80s and 90s. So let's say, well, throughout the 80s and even into the early and mid 90s. How many of you had a computer in the mid 90s? 95, 94, 96, something like that. Remember what kind of computer it was? Speed or anything? You had a Mac? You have much memory? Remember any specs on yours?
I had it was the 2GS, that was a little before, but I still had it, but that was actually 1 meg.
Okay. In 1990, was it 1995, we had a 486 DX2 66 megahertz computer we bought from Sears. We had to wait for them to release the processor, the chip, hot off the press. 66 megahertz, right off the press. It had a 420 megabyte hard drive and 8 megabytes of RAM. About a year later, I decided I wanted to upgrade the RAM and the hard drive. I wanted to take it up to a gigabyte of hard drive space, which obviously just sounded awesome, right? It's like unlimited hard drive space back then. Gigabyte is 1,024 megabytes. So I got a 500 and some odd megabyte hard drive, came up just short of a gigabyte, I think. And I also wanted to double my memory. So I went from 8 megabytes of RAM to 16 megabytes of RAM. How many of you have upgraded RAM in your computers anytime recently? What did you go from to what? 1 to 2 gig or from 2 gig? 1 to 2 gig, okay. SD RAM?
Yes.
Okay. And did you have to get rid of your 1 gig chip and just put a second 1 gig chip in, or did you have to go to 2 1 gig chips, or were you able to keep your existing RAM and just add to it?
I put 2 1 gigs.
Okay, 2 1 gigs. What did you have in there before? 2 512s? Yeah. Okay, so you dumped the 2 512s and put in 2 1 gig chips. Okay, so you basically burned your own old memory and had to buy the entire 2 gigabytes fresh, right? How much did that 2 gigabytes of RAM cost you?
Well, being an old XP, it was like $40.
And you thought that was expensive?
I know that's cheap.
Yep. So let's say that you have a newer computer. So let's say that you buy a, here we'll use your machine as an example. So chances are you have you said you have a 26-inch or 27-inch iMac. It probably came with 8 gigabytes of RAM, would be my guess. You can double that to 16 gigabytes. So we're going to put another 8 gigabytes of RAM into your machine. Okay, 4 times more memory than his machine has max. Okay, is what we're going to add to yours. That's probably going to run us about $100. Something in that ballpark. Cheap. Okay, big scheme of things, cheap. When I went from 8 megabytes of RAM to 16 megabytes of RAM, megabytes, how much do you think that cost? $1,000. An 8 megabyte chip cost me $1,000 in 1995-ish or something like that. Memory is not a problem today. We have solved that problem. Memory was a prohibitive problem in the 80s and 90s. Significant problem. Famous guy, maybe you've heard of him, Bill Gates, Microsoft dude, right? He's famous for a quote he once made related to memory. Anybody know the quote? Said, "You will never need more than 32K of memory." Never. 32 kilobytes of memory. Not megabytes. Kilobytes of memory. Never need more of that. Yes, you do. In a calculator. Our calculators have more memory than that. So, our position on memory is much different today than it was back then. C, the C programming language, comes from a time period where memory was a precious resource. You should only use a variable to store the size of information that was most appropriate for what you were doing. We don't care about that today. If I need to store a really tiny number and I want to put it inside of a dump truck, who cares? I have unlimited space. We have 8 gigabytes of RAM we don't know what to do with, and for $100 we can double it, right? So this is a laptop. 16 gigabytes of RAM. A laptop. What do we need that for? I'll tell you what, in 10 years, we'll be joking like, oh, machines used to only have 16 gigabytes of RAM in it. How did you function? All right, so getting back to our list here. A byte is an 8-bit signed integer. By signed, I mean it can hold positive and negative numbers. So the range of values that could fit inside of 8 bits is negative 127 to positive 128. So the byte primitive type could hold numbers in that range. Negative 127 to positive 128. All right. Then we have 16-bit. A short is a 16-bit signed integer, which can hold values in the range of negative 32,760. Actually, hold on. This is negative 128 to positive 127. This one's negative 32,768 to positive 32,767. And the way you come up with these numbers is this is plus or minus 2 to the 7th power is what that one is. This one is plus or minus 2 to the 15th power, because we have to use one of the bits for the sign to keep track of whether it's positive or negative. So that's why this one's 2 to the 7th, this one's 2 to the 15th. 8-bit number, 16-bit number. Make sense? Okay. An int, 32-bit signed integer. And this guy is plus or minus 2 billion. So plus or minus 2 to the 31st power. A long is a 64-bit signed integer. And this is plus or minus giant number. Notice how my precision goes downhill? Maybe one day, after I've been doing this for 50 years, I'll get closer on the 2 billion and I'll actually try at this one. This is my 15th year teaching, so I'm accurate up to the short. All right. Now, next primitive type is a char. These are for character types. What's a char? A char is a 16-bit unsigned integer. Wait a minute, I thought we just said that they're characters. Oh, they're 16-bit unsigned integers. Holds the value 0 to 65,535. You'll notice that if you add these two numbers together, 32,768 and 32,767, you'll get 65,535. You get this range, because this one's unsigned as opposed to signed. So chars only are positive, 0 or more. So that's 2 to the 16th power is 65,535. So now, why are chars integer types? We have something called character sets. So a character set you may have heard of is called ASCII. American Standard Code for Information Interchange is what it stands for. ASCII is an 8-bit character set of the English letters. So there are 256 unique characters in the ASCII character set. Now, the problem is, so ASCII came out in relatively early days of computing. And you may not have noticed, but Americans tend to be fairly self-centered. Surely the rest of the world is all going to speak English, right? They're just going to use our symbols and stuff like that. So all we need is ASCII. Well, would you agree that other countries also have access to computers and the internet and things like that now? We have a problem. ASCII doesn't have enough space. Even though we're not using all 256. I think we're using like 147 or something like that for, You know, then we filled in the rest with like little like smiley faces and things like that. You've probably seen it before when like a program messes up on your computer or something. You'll see like weird symbols come out. You see smiley faces and like the character representation of like playing cards. Have you seen those before? Those are just the random ASCII fillers. So in any case, ASCII was not good enough to really cover a global community. So we have something called Unicode. And Unicode is a superset of ASCII. So the first 256 characters of Unicode are the ASCII character set. So Unicode has 65,536 unique characters covering, I'm sure it's not all, but covering most of the unique symbols across all the world's languages. An effort's been made. Okay? So that's what Unicode is. 0 to 65,535 is the actual numeric values. And what a character set is it's a list of numbers, index numbers, so 0, 1, 2, all the way up to 65,535, with corresponding characters to each of those. Why is that? When we're dealing with characters, human beings like seeing characters, right? We want to see the actual characters on the screen. We don't want to have to go and look up numbers and stuff. Computers still like numbers. So, you know, I'm saying it's 0, 1, and 2, all the way up to 65,535, but the reality is computers are going to represent each of those in binary. Zeros and ones. We'll talk about that here in a second. But these character sets, what they allow us to do is they allow us as programmers to work with things in terms of their characters. But the character sets allow the computer to easily map between the two, the numeric equivalent and the character itself. Okay, and we'll see plenty of examples of this stuff. All right, so that's the deal with character sets. Now, here. For all of these, I'm saying this is 8 bits, this is 16 bits, this is 32 bits, this is 64 bits. What's a bit? What is a bit?
8 units.
Nope.
Single character.
Either 1 or
0 or a 1. That's what a bit is. What's a byte?
8 units.
A byte is 8 bits. What's a kilobit? 1,024 bits. What's a kilobyte? Big B. 1,024 bytes. What's a megabit? Thousand 24 kilobits. What's a megabyte? 1,024 kilobytes. What's a gigabit? 1,024 megabits. What's a gigabyte? 1,024 megabytes. What's a terabit? 1,024 gigabits. Terabyte is 1,024 gigabytes. Anybody know what comes after terabyte? I think it's petabyte and then exabyte. So those would be the next two. Now, we wouldn't have thought we needed any more than gigabyte for a while, but now you can go out and get a 3 terabyte hard drive at Best Buy for $150, right? What is that? That's over 3,000 gigabytes. Okay, so now some interesting stuff. One of my, I guess one of my hobbies is I like to bring awareness to Best Buy shoppers, so you don't get taken advantage of at Best Buy. How many of you have internet at home? All of you have internet at home? Who has DSL? Who has cable? Who doesn't know what they have? Who has dial-up? Satellite? What are you using as your internet? Your phone? Okay. Okay. So, those of you who have cable, how fast is your internet connection? Who said they have cable? Time Warner's got a bunch of different packages. Which is the one you have?
One is 3 and one is 15. I can't remember which one's down, which one's up.
Okay, well 15 would be down. So download speed is going to be faster than your upload speed on all consumer internet. So we got 15 down, 3 up. Well, we have whatever Time Warner gives me. What else we got? Let's make something up. 30 meg down? Okay. Is that megabit or megabyte? Or just meg because it sounds more neutral? Well, you said you use your phone. Who's your carrier?
USO.
Okay.
Thinking about varies, of course, how far away from the tower. I usually get 16 down, about 10
16 what down?
megabytes.
Okay. Take that to the bank. Sure on the 16 megabytes? Are you an LTE? US Cellular's LTE? Okay. Have you, so let's see. When you download stuff on your computer, it's usually measuring in kilobytes per second, right? It's usually your download speed. So, let's do some math. So you're telling me you have 16 megabytes per second. No, we're gonna do it. You don't have that, but I'm gonna show you why. Okay, so 16. We're gonna go back to our chart here. We want to get back to kilobytes per second that we're getting our download, right? So 1 megabyte is 1,024 kilobytes. So 16 times 1,024 is 16,384 kilobytes a second. Probably not getting that. Most download sites, I would say, when you're pulling something down from your phone, because it jumps, as you said, that's the disadvantage of phones. Anymore, actually, the LTE cellular technologies are outpacing cable modems in terms of, or outpacing a lot of home-based internet in terms of maximum capable speed. The problem is sustaining that speed because you're at a fairly noisy connection, I guess. Realistically, most things you download, you're probably getting between 2 and 800K a second. Most things you might download, not 16,000K a second. So, if you were to go out and get the fastest Time Warner internet here in town that they offer right now, they're about to double it actually, you would get 50 megabit per second. internet. You said you have 15 megabit per second. That's what your download is, 15 megabit. Which means if we convert megabit to kilobyte, we should see what our capability is. So you have 15 megabit. So we're going to do 15 times 1024 to get us to kilobits. Divided by 8 to get us to bytes. Divided by 1024. Hold on, we did this wrong. I need to do it a second time. Hold on. So we're going to do 15 times 1024 times 1024 divided by 8 divided by 1024. So your maximum download speed is 1,920 kilobytes a second. That's what theoretical maximum. You still can only download as fast as somebody else can upload to you. So whoever you're downloading from is going to possibly limit your, how fast you can download. So if you're downloading from Google or Apple or something like that, you can probably hit that. If you're downloading from Bob's Pizza Parlor, probably not going to maximize your internet connection. People who have 50 megabit can get about 6,400 kilobytes a second, or about 6.25 megabytes every second. That's your maximum theoretical speed. Again, unless you're downloading from one of the giant pipes like Apple or Google or something like that, you're not going to get that speed from most places. So why get 50 megabit? Just because you like giving Time Warner your money? How many of you only have one computer in your house? Let's actually take that a step further. How many of you have only one internet connected device in your house? So things start adding up, right? So a lot of people have a desktop and a laptop, or have a desktop, a laptop, and a couple of cell phones, and an iPad, and a Netflix box, and yeah. So that's where these higher speed internet things come in handy. If you have 50 megabit per second bandwidth available to you, you could have 2 people watching Netflix at the same time, plus somebody else playing an online video game, plus your download going for 2 or 3 different things, and you still have some bandwidth left over. Make sense? Okay, if you have the whatever Time Warner gives me internet, which may be fast, may be slow. We don't know what she's dealing with. It's a crapshoot is what it comes out to. So if you go with like Time Warner's Budget Pleaser, they have I think maybe a $15 a month internet. So like, hey, I can check my email. It's probably I think 3 megabit down by 256 kilobit up. Which is back in the day, that was considered really, really fast. Like really fast. But by today's standards, that's very slow. That's not something you're going to be able to do a lot of things at the same time. You could probably do Netflix on that. But that's all you're going to be doing is Netflix. So kind of an interesting thing, I talk a lot about this in my networking classes, is, so back to movie references. How many of you have heard in movies them reference T1 lines? It's like, oh man, wouldn't it be awesome if we had a fast internet connection like a T1? How many of you would want a T1 today? It's like, I'm not sure. Is it fast? Is it slow? It still sounds cool, right? T1 is 1.44 megabit per second. Synchronous, so it's up and down. So you do get it pretty fast. So yours is 15 megabit down by 3 up, right? So your upload speed is twice the speed of a T1. and your download speed is 10 times the speed of a T1. You don't want a T1. You want what you got, right? If you bought a T1 today from the phone company, it would probably cost you about $3,000 a month because it's a dedicated circuit. So yeah, just interesting historical things where things that used to be cool would now actually be huge downgrades. And same thing, like he's using his phone as his internet. And you haven't had issues with that at this point? It's consistent enough where you don't do any gaming or Netflix. So on Netflix, you can probably pull off on there. Are you on unlimited data?
Yes.
So,
Rarity.
okay, with tethering.
Yes.
Do you have to pay for tethering or it came with it?
Came with package.
It's a pretty slick package, LTE with unlimited. And they don't throttle you? Yet. The US sellers are usually pretty good with their customers. You know, they're the small guy, but they usually don't screw around with their customers too much. Now, that's a pretty decent deal. It's like here in Mequon, I'm on AT&T's LTE, and we get a lot faster bandwidth than US Cellular, but US Cellular is very new to the LTE arena. I've gotten a couple like 60, 65 megabit per second down on my cell phone. What are you going to use that for? You know, and I've gotten something like 40 or 50 megabit up on my cell phone. But at the same time, if I ran that test 5 times in a row, I might get 65 megabit down 1 second, and then 12 down the next, and 12 is still okay. But not when you just got 65. It's garbage, right? So in any case, understanding where the bits and bytes and all these things collide is an important aspect for technologists, whether you're IT or computer science. So being IT majors, every one of you should know how fast your internet connection is. Okay, so it's secondary homework assignment. Won't be graded, but that's something you should know as IT professionals. Okay, you're the people that should know what the technology you have at home is and what the technology your customers or the people you're working with may have at home. You have to be the ones in the know. Make sense? Okay, so if you don't know what your home internet is, I would encourage you to get those details so you have an appreciation for what you have, what you're paying for, and how you use it. You know, I have 50 megabit at home, and as soon as they go to 100, I'll get the 100. But I use my internet a lot. It's not uncommon for me to have Netflix on in one room, my wife have it on another, and I'm downloading something or playing games on my laptop or whatever. You know, I've been known to maximize my internet connection for various reasons. But if you're somebody who watches Netflix once or twice a week and checks email otherwise, you may have gotten talked into buying a, you know, their mid-tier, like the 30 megabit down is, you know, that's their wideband, but their lower wideband speed. You may have gotten talked into that. You might be paying $50 or $60 a month for internet, and you're wasting your money. Get the budget pleaser one. Still let you do Netflix. Still let you check your email and go out for pizza, something like that. Probably go out for pizza 2 or 3 times. All right, so having said that, back to this slide where we talk about these being represented as bits. So a byte is 8 bits. A short is 16 bits. An int is 32 bits. Again, a bit is a, actually let me back off here. A bit is a 0 or 1, right? So a byte would be 8 bits. So that's an example of a byte. A sequence of 8 zeros and ones. Okay? So now, remember that a byte primitive type is a signed number. So one of those bits is used for the sign, positive or negative. So we actually only functionally can use 7 of those bits for a byte. So that means the biggest byte number we can have is that. All right. Now, let's say I gave you the number. I'll still put it in byte format. So that's the number 101 in binary, padded out to a byte for your convenience. Okay, so all these numbers out front don't mean anything, and I'll show you why. What is the decimal equivalent of that number? This is the binary number 101. That is the base 2 number. So this is the ones place, twos place, fours place. So this is 1 times 4 plus, put these in parentheses. Actually, let me just walk it from the end, because you usually go from right to left. So I'm going to say we have 1 times 1 for the ones place, plus 0 times 2 for the twos place, plus 1 times 4 for the fours place. Keeps jumping by 2 because this is base 2. Ones place, twos, fours, eights, 16s, 32s, 64s, 128s. Okay, so this is the number 5. If I threw one more 1 on there, this would be plus 1 times 8. So now this is 13. Make sense? Okay. Now, the important thing to recognize there, and we're going to look at this in more depth at one of your homework assignments, is this is not dissimilar from the way we're already used to counting. What number is that? Not a trick question. 275, right? How'd you come up with that? What place is this? Far right. It's the ones place, right? Tens place. Hundreds place. We jump by tens. So this is 5 times 1 plus 7 times 10 plus 2 times 100. So that's 200 plus 70 plus 5. 275. Make sense? So the different bases doesn't make any difference. It's the exact same algorithm for converting between bases regardless of the base. You just have to not psych yourself out. But in any case, that's where all this bit-byte stuff comes from. All this crap over here. Okay? So, byte, shorts, ints, longs are all signed integer types for storing signed whole numbers. The reality is let's say 95% of the time you're just going to use int. If int isn't big enough, you'll use a long. If a long isn't big enough, we have some object types to fix that. Okay? So, int is, if I need to hold the whole number, put it in an int. Long, big whole numbers. You'll never use a short, you'll never use a byte. There actually probably are some situations where you might use a byte if you're doing a program related to like streaming audio or video where things are coming in 1 byte at a time. I can safely say you will very, 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 very rarely use a short, if ever. You'd have to be using somebody's old library that they wrote when shorts meant something. So this is something you'll never use. And bytes you'll hardly ever use. You'll use ints a lot and longs sometimes. Chars, this is a convenience. We use chars all the time. They're 16 bits. Why? Because they represent the Unicode character set. We need to be able to hold 65,536 unique characters. That's why they're 16 bits. They're unsigned because we don't need negative numbers. Because we just need to be able to index the Unicode character set from 0 to 65,535. Floats are 32-bit dot 32-bit signed floating point numbers, or signed decimal numbers. A double is a 64-bit dot 64-bit signed decimal numbers. So floats and doubles are kind of like the int and long of floating point numbers. So these can hold like 3.14 and 2.76, those kind of values, not whole numbers. Ints don't know how to hold decimal places. If I tried to shove 3.14 into an int, it'd become a 3. And we'll see plenty of examples of that. Booleans, in actuality, a Boolean is a 8-bit unsigned integer, of which we actually need 1 bit. Booleans are represented as zeros and ones in the underlying language C and C++. Java hides the numeric side of Booleans from us. We can't actually get to the numbers in Java. So from our perspective, Boolean is either true or false. Those are the values that a Boolean can hold. It's either true or it's false. But under the hood is represented numerically, just like all the other crap. Okay? Computers like numbers. People like numbers to an extent. All right, questions about our primitive types here. Okay. So up to this point, because remember, we have 2 types of variables. We have primitive types, we have object types. We're not going to talk about object types for a while. Several classes, probably maybe week 3 or 4 is when we'll hit object types. We'll have plenty of stuff to do with primitive types before that. Now we need to look at variable definition syntax. How do we actually define a variable? We know what variables are. We know what our types are now. We know, well, at this point we know about all the primitive types, and we know that we have these object types that don't actually exist in our world yet. Okay? They're there, but we're not going to use them yet. So now we know what the types are, we know what variables are. How do we actually define one of these guys? How do we write the code to really define a variable? The generic syntax for defining a variable is type followed by variable name equals value, semicolon. And formally, I would put square brackets here, not because it's part of the syntax, because what I have highlighted there is optional. You do not have to give a value when you're defining a variable. So I can define a variable like that, or I can define a variable like that. So as an example, I could say int a is equal to 5. So I defined a variable named a of type integer, which is a 32-bit signed whole number, and I gave it an initial value of 5. Similarly, I could say int b. By doing that, I've defined a variable named b. So I've gone to Target, bought a bucket, put it in memory someplace, said, you hold ints. His name is b, but I haven't actually put a value in there. So this guy is a, capable of holding an int, actually holds an int 5. This guy is B, capable of holding it, nothing's in the bucket. So I better put something in there before I use it. Make sense? Okay. Let's see. Numeric operators. So now that we can create variables, we need to be able to do things with our variables. So we have plus, minus, times, divide. So your common ones. And then we have the percent sign, which is modulus. Anybody know what modulus is?
The quotient.
I think you're talking about the right thing. How many of you had third grade math? Some of the other countries, it might have been a different thing, but I've taught grad courses for a while, so, and typically in technology, we have mostly non-American students. It's undergrads primarily American, graduates primarily non-American. It's actually interesting. So I think third grade is about where it happens everywhere. Remember long division? We love long division, right? I remember I was a little third grader and picking my nose. I was probably a really crappy third grader. So when we did long division, so if we had 13 divided by 5 in long division, 5 goes into 13 how many times? 2 with remainder 3. Correct? Okay. So if I were to take 13 and divide it by 5 in Java, I would get the 2. If I did 13 and I modded it by the 5 in Java, I would get the 3. So the modulus operator gives me the remainder of integer division. So going back to our operators here, here are our numeric operators. We have plus, minus, times, divide, and modulus. If these guys are operating on ints, integers, whole numbers, so the guy that's on the left here, 13, is a whole number, right? The guy that's on the right here, 5, whole number. So that means that this division operator, we are doing integer division. And integer division does what's called truncates. Integers do not know how to hold decimal places. So we cut off the decimal place. So 13 divided by 5 is 2 point something, right? Well, in integer division, it's 2. If I want to get what's left over, I do the 13 mod 5. I use the percent sign, and that allows me to get the remainder, the long division integer remainder. Make sense? Now, how many of you have used the remainder of long division anytime recently? Third grade math really came in handy, didn't it? You certainly used it this week so far. We're almost to Thursday. Nobody? Nobody used the remainder of long division this week? How about this year? We're a month in. This decade? What's interesting is Modulus is probably one of the most powerful tools we have as programmers. We use it a lot as programmers. For example, let's say I'm interested in finding out if a number is even or odd. What does it mean for a number to be even? Evenly divisible by 2. Well, what does it mean to be evenly divisible by 2? When I divide it by 2, it has a remainder of nothing. It's a remainder of 0. Make sense? So that's just a simple case. And we deal with prime numbers and things like that. Modulus comes into play a lot. So kind of an interesting thing how something we learned in 3rd grade is actually fairly important in computer programming. Those of you who have cell phones, even your flip phone might have this. When you turn your flip phone on, or any of your phones, you have maybe seen something that pops up on the screen that says RSA. It's a security protocol. Have you ever seen that before? Huh? Okay, good. RSA, yeah, it's an encryption algorithm, is actually based on a really interesting math principle. It's based on the inability to factor 2 large primes out of a big number. So the concept is this: you generate 2 gigantic prime numbers. You multiply those numbers together, giving you a giant number. It is mathematically nearly impossible to efficiently get those original 2 prime numbers back out. It's computationally impossible. And that's all based on modulus as well. The amount of time it would take so many generations to brute force go through it, to factor out those 2 prime numbers. Just interesting stuff. And that actually comes from a problem we were talking about earlier with our computers are getting too fast for our own good. Historically, security algorithms, we just kept upping the bits. Like, oh, well, this is a 128-bit encryption key. Well, now we know what bits mean, right? 128 bits means that your key, your password, is 128 zeros and ones long. So how many unique passwords are there? There's 2 to the 128th power unique passwords. Well, that's a big number, right? Well, maybe not big enough, so let's do a 256-bit key. What about a gigabit key? So 1,024-bit key. So on and so forth, blah, blah, blah. At what point is the key big enough for today's computational power? With the idea being this: if you have a gigabit key, that means your password is 1,024 bits. Well, actually, no, gigabit key would be way bigger than that. It'd be 1,024 times 1,024 times 1,024 bits long. Huge, huge key, right? How many unique passwords are there? Well, that would be 2 to the 1,024 times 1,024 times 1,024 power. Gigantic number, right? Is that big enough? So that it would be computationally impossible for today's computers to be able to take more than a lifetime to brute force crack your password? Assuming your password's somewhere in the middle of that list. Would it take more than a lifetime for us to go through all of those zillions and zillions and zillions of passwords and eventually crack your password? Well, maybe. But now we have another problem with these types of problems today. And that is distributed computing. So our computers are fast, and they keep getting faster, right? Well, now all of our computers are networked together, aren't they? Well, so is it 10 computers faster than 1 computer? If you take 10 identical computers, you network them together, now you have 10 times the horsepower. If you split up the problem, you have a tenth of the problem of the first computer, a tenth of the problem of the second computer, a tenth of the problem of the third computer, so on and so forth. You just cut your time to solution down by 10 times, right? Tenth the time it'll take to solve it. But do we have more than 10 computers on a network? Millions and millions of computers are on the internet, right? If you want to help search for UFOs, you can go to a website, SETI at Home. You can download their little client, install it on your computer. And what it'll do is it'll use your computer's idle CPU cycles when your computer isn't doing anything. It's like, whoa, I just spent $3,000 on my computer. It's always busy. Statistics say that your computer is idle about 97% of the time. That means it's just using your electricity 97% of the time. So you might as well be hunting for aliens. So then there's some other things like that. There's another one called Folding at Home, which is a physics research tool, I think out of Stanford University, where you install it on your computer, and when your computer isn't busy doing your stuff, so it only uses CPU power when you're not using CPU power, you're helping researchers study the, whatever, mysteries of the universe or something like that. But punchline here is that this concept of security and making bigger and bigger secure keys, it really goes out the window by today's standards, because we literally almost have infinite computing power, right? And every year it keeps tripling. So we're just adding more cores. And we're adding more machines. Now I think you can search for aliens on your smartphone. Very bad for your battery. Only do it while charging. All right, so kind of makes sense. I'm trying to just give us the environment that we're living in with all these bits and bytes and things like that. Okay, so numeric operators, here's these guys. Then we have our Boolean operators. But in order to talk about Boolean operators, we have to first talk about Boolean expressions. What is a Boolean expression? A Boolean expression is any expression that boils down to a single value of true or false. That's what a Boolean expression is. It's any expression that boils down to a single value of true or false. And to build Boolean expressions, we have Boolean operators. Well, first ones, most of which we should be fairly familiar with. Less than, greater than, less than or equal to, greater than or equal to, not equal to. So these guys are the numeric Boolean operators for comparing numbers to each other. Is one number less than another number? And interesting note, all these ones that have two characters, no space. They have to be run together. So, as an example, 5 less than 4. Is that true? No, it's false. Is that a Boolean expression? Boolean expression. Any expression that boils down to a single value of true or false. This guy boils down to false. That's a Boolean expression. 4 not equal to 5. True statement. That's a Boolean expression. Let me give you a couple other operators. So these are our numeric Boolean operators. Here are our logical Boolean operators. We have and, or, we'll start with these. In a second, I'll show you bitwise ones that you'll never use, but just for completeness. So these are ands and ors. So I could say something like 5 less than 4 or 4 not equal to 4. Is 5 less than 4? No. So we know that this part of it's false, correct? Is it true that 4 is not equal to 4? That's a true statement. 4 is not equal to 4. It's a false statement. Okay, so this is false. They are equal. So I have false or false. False or false will boil down to false. For an or to be true, only one side needs to be true. For a one or more sides needs to be true. It can both be true, but at least one side needs to be true. For an and to be true, both sides need to be true. So I could say something like 5 is less than 10 or 7 greater than 8. Is 5 less than 10? Yes, that's true. Because this is an or, I don't even need to check the other Boolean expression. I have one true already. That's good enough. So this is true or false, doesn't matter, the whole thing's true. So this whole expression boils down to true, which is a single value of true or false, right? This side's true. This side's false. False or true is true. Make sense? Similarly, 5 less than 10 and 10 less than 20 boils down to true. 5 less than 10, that's true. 10 less than 20, that's true. True and true is true. All right, that makes sense? So are we Boolean expression experts now? Okay, here's I'm gonna true or true. What does that boil down to? True. For an or, only at least one side must be true, right? In this case, both of them were. True and true. What's that boil down to? Is that a Boolean expression? How many people think yes, that is a Boolean expression? So we're getting some people testing the waters. I got what we're gonna call this. He's a pretty big guy. We'll call this 1.5 people. So I have 1.5 people who think this is a Boolean expression. Who thinks this is not a Boolean expression? Half a person. You got non-voters. Presidential year, I guess. What do you think? Boolean expression, not a Boolean expression? What's a Boolean expression?
It didn't.
Any expression that boils down to a single value of true or false. Is that a single value of true or false? Yeah, it's a Boolean expression. Not a very interesting one, but it is a Boolean expression. So is that. What about that? Well, I put false above, true above. They were both Boolean expressions. Why isn't this one? No, it's not a single value of true or false. That's an integer. All right, makes sense? So, how are we going to use our Boolean expressions? Let's go all the way back up. Where's my how people solve problems? There we go. So this is back to our how do humans solve problems slide. Well, number one on there was memory, variables. We've talked about those pretty well, right? We know the different types for primitive types. We now know how to define them. We now know how to, with numbers, create Boolean expressions. We now know how to create Boolean expressions in general. We haven't really used variables for anything at this point. We've looked at our arithmetic operators. So I can certainly do something along the lines of int a is equal to 5, int b is equal to a plus 2, int c is equal to b times 2, something like that. So in this case, a is 5, b is 7, c is 14. Make sense? So there's some variables in action. So the next thing on that list, though, is how do people solve problems? We solve problems by asking questions. This is accomplished through if statements, conditional statements in programming languages. And so we come down here. We look at the if statement. Syntax. The if statement syntax is as follows. The word if, all lowercase. Java, like most programming languages, is case sensitive. It cares whether you did upper or lowercase and all that crap. So that's a lowercase if, followed by an opening parenthesis, followed by a Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. So if Boolean expression, opening curly brace, closing curly brace, logic in the middle. Pretend like the dots aren't there. I'm having to repurpose Keynote. So syntax for an if statement is the word if, followed by an opening parenthesis, followed by some Boolean expression, followed by a closing parenthesis. Then we have an opening and closing curly brace. And inside that is the logic to do when the expression is true. So we will only execute this logic inside this opening, closing curly brace if the Boolean expression up here is true. So we're asking a question. If this is true, do this crap. Optionally, we can have an else. Logic to do when the expression is false. So we can ask a question, respond to it if it's true. Similarly, we can ask a question and we can respond to it if it's false. If we'd like. The else is not required. It is an optional part of the if statement. So I could do something like this. So we'll say int a equals 5. Oh, hold on, this just that's fine. It's gonna work with it. So we'll say int a equals 5, int b is equal to 7. If a is less than b, c is equal to a times 2. Else c is equal to b times 2. So here's some code. We define two variables, a and b. Start a off at 5, b off at 7. We defined a third variable but didn't give it a value yet. Then we ask a question. If a is less than b, a is 5, b is 7. Is 5 less than 7? Is that a true statement? 5 is less than 7? Yep. So this is true. So we'll get into the first block of code here, which says c gets the value a multiplied by 2. So c should equal to 10. So we will not do anything with this else because the Boolean expression boiled down to true. So we just skip past the else and we'll be right here. So when we get to the line that says here, c will be equal to 10, right? If I change this original variable a from 5 to 8, now is 8 less than 7? No, that's false. So we'll skip past the Boolean, the true block structure and go into the else, where we say c is equal to b times 2, which is 7 times 2. So when I get to the line that says here, c is equal to 14. Make sense? So that's an example of asking questions. Now, let's say I did not have the else here. As it currently stands, a is 8, b is 7. Is 8 less than 7? No. So I'm going to skip past this block. I did not include an else this time. It's optional. So I'm not going to do anything. So I get to this line right now, right here. What is the current value of c? I never actually gave it one, right? It will have a default value, but you should pretend like you didn't hear me say that. It'll probably be 0. But you should never, ever, ever rely on default values. If you want a variable to have a value, give it a value. So as far as we're concerned right now, we would probably get an error in our code, or at least a warning that said C may not have been initialized. So if I had the code in here to print out C, it might yell at me saying, look, it's only possible you ever gave C a value because you may not have gotten inside this if statement. Make sense? Okay. Now, on the other hand, if I would start C off at -1 up there, and then only optionally change it to A times 2, as it currently stands, is A less than 7? No. What is C? C is still -1. If I changed A to 6, 6 less than 7? Yep. So C becomes 6 times 2, which is 12. What is C? We overwrote the -1 with a 12. Make sense? So that's how we ask questions. So this example has us defining some variables, using some variables, setting variables to new values because they are variables, so we can vary the value that's in them, and asking questions. So this sets us up for next time dealing with repetition. But rather than talk about that right now, I want to talk about your homework assignment first. Make sure you guys are clear on that. So I'll save this. Let's go to our assignments here. So like I said, you have 2 assignments for next week. You have a paper and you have a programming assignment. The good news is this first programming assignment should be relatively easy. It's actually my way of making sure that you have your development environment set up. So I'll talk through the assignments here in a second. So under Angel, it's going to be in lessons. It'll be in Unit 1. Again, remember to read the homework directions and self-assessment template thing. Make sure you turn that in for both of the assignments. So step 1 and step 2 say watch these videos. You just watch them. Okay, we were sitting here. So homework number 1. Research how to write, compile, and run the typical Hello World program in Java. This is a program that outputs to the screen Hello World. Write a tutorial that walks someone new to programming through the process of creating, compiling, and running this program. Hand in this tutorial. So, you're going to research how to do this in Java. I would encourage you to look how to do this with a tool called Eclipse. It's free. It'll work in any of your computers. Java will work on any of your computers. Mac, PC, doesn't matter. That's why we use Java as a teaching language. Platform independence for the win. All right, so I would encourage you to investigate Eclipse for this. It'll make your life easier and also be consistent with what we're going to do in class. But if you'd like to do it the old school way and just do a brute force Java program without using any tool, have at it. Okay, so this first one is to write a tutorial. This is using your kind of your IT background where you're teaching somebody who doesn't have the background that you have how to do something that might be technically challenging. Make sense? Okay, writing a Hello World program should be very, very easy. I could have the Hello World program written between now and 40 seconds from now. So we're not talking about a lot of work, okay? Just some research to get you up to speed. So that's the programming assignment. Questions on that?
Do we hand in our version of that program or just the tutorial?
Just the tutorial. Yeah, so it'd be kind of like almost like a paper, if you will, but and there's no length limit to the tutorial. I mean, if you can accomplish it in 2 pages, great. If it takes you 15, fine. You can put pictures in it if you want. So I'm not going to grade it based on how long it is. I'm going to grade it based on how accurate would be, I'm going to sit there and pretend like I'm somebody who's never done this before. Is it a set of unambiguous instructions that would tell me how to accomplish this? Or does it leave a lot to be desired and I have to fill in the blanks? Kind of like if you gave me instructions for making a lasagna and you left 3/4 of the ingredients out just because you assume I know how to cook.
We
So.
can just write in a doc file and post it in the.
Yep. All right. So then that's the programming assignment for the week. Your report for the week, report number 1. Create a 3 to 5 page report covering the role of Java in industry today compared to C# and Objective-C. Your report should cover what are the advantages and disadvantages of Java as compared to the other two. Your report should include a use case describing the career path of a Java developer in the IT industry. What can one expect to be doing as an entry-level Java developer? What can one expect to be doing as a senior-level Java developer? What are the expectations in the journey between those two positions? Make sense? So some of that content we covered in class today. The other content you're going to have to research in terms of what are the requirements for, like, you'll look at jobs. Somebody who's hiring for an entry-level Java program, what are their expectations? Somebody who's hiring for a senior-level Java programmer, what are their expectations? So on and so forth. No specific writing style. I don't care about footnotes and bibliography, things like that. I'm looking for content. So a couple important things with writing. Proofread your work. If you have problems writing in English, go to the writing center and have them help preview your paper. Ultimately, what I want you to turn is something that I can put in front of anybody and it would read fine. So can't be broken English, no misspellings, or expect to be hit on points if you have misspellings. So take the time to proofread your work. I am not an English professor, so if you use some questionable grammar, I'm probably not going to hit you on that unless it's just absolutely incorrect. My grammar isn't the best in the world. That's why I have my wife. I wouldn't have gotten through my dissertation if I didn't have her to proofread it. So in any case, I don't care about your sources. You don't have to write a bibliography. You don't have to footnote stuff. Don't copy off each other, but I get you're going to be using the internet for a lot of your resources. So, I'm not looking for plagiarism. I'm looking for your ideas, well thought out, that kind of stuff. You're only hurting yourself if you want to cheat or something. So, questions about that?
Any particular font?
I don't care. Whatever makes you happy. If you want to double space it, that's fine. If you want to single space it, I basically just something in the 3 to 5 page-ish range. If you want to take more space, which I'm sure all of you will do, feel free. If you think you can say everything I'm looking for in 2.9 pages, heavily spaced, I doubt that's the case, but I'm not going to give you a 0 because it didn't hit 3 pages. I'm going to look at your content. Make sense? Questions, comments, concerns, bribes? All right, I will see everybody next Wednesday.